Now see some practical example of friction. So one of the very interesting and example is your walking. Now, walking is possible only because of the friction. See, walking is possible because of the friction means let this is your ground, and how the walking occurs. Whenever a person walks, so he presses the ground in the backward direction like that. When he put his foot on the ground, he presses the ground in the backward direction, so that because of that his foot have tendency to go in the backward direction. So then the ground is applying a friction force in the forward direction, and because of that friction he is able to move. As we have experienced, suppose the surface is a little bit smooth, or if we are talking about ice, in case of ice or smooth surface or oily surface, even we are applying a force in the backward direction, but since the friction here negligible or not present, so that friction here not present, so there is a very difficult to move in the forward direction. The walking is because of the friction. So when a person walk, he pushes ground in the backward direction. So his tendency of motion of the foot in the backward direction. His tendency of motion of foot in backward direction. So ground is applying friction force in the forward direction. Because of that force, he is able to move. Similarly, another very interesting example is here in automobile. In automobile means motion of a bicycle or bike or motor car. Automobile is also very important. This automobile means the motion of bicycle, or motorbike or motor car. All are because of the friction. If friction is not there, then these automobile means your wheel is unable to move. For example, if we are considering the bicycle case, in case of a bicycle, so we can have these are the two wheels of the bicycle, and these wheels are connected with a chain and sprocket system like this. So what happens when we are making a paddling? Here some paddling we have to make. So when we are making a paddling, it means we are applying a tension on the upper part of the chain. Because of this tension, this provides a torque and the wheel rotate. So when the wheel rotates, this point of contact have tendency to go in the backward direction. So when the point of contact is going in the backward direction, then the friction force here act in the forward direction. This is the for rear wheel. Now, because of that friction force, this wheel start your moving, and with the rod or with the shaft, forward wheel is also attached. So as the backward wheel will slide, the forward wheel, since attached with the same rod, that is also give the sliding motion to the front wheel. So as the front wheel point of contact slide in this direction, the friction force in the front wheel will be in the backward direction F dash. This is your front wheel. And this is the case at the time of paddling. When both at the time of paddling. Suppose no paddling but wheel is still moving. So in that case, in both the wheel, friction act in the backward direction. So no paddling. And wheel is moving in this direction. So this is the condition here. When no paddling, then in both the wheel, friction act in the backward direction, and when the paddling, then the friction in the rear wheel act in the forward direction, and in the front wheel it will act in the backward direction. So these are very, very interesting and very important practical application. Without these, without the friction, walking as well as wheel cannot move on the road. So now come to the certain numerical example based on the friction. See the one example. In this question is given as, suppose this is your vertical wall, and on this vertical wall a force F has been applied, and that force makes an angle 30 degree with the horizontal to keeping the block at rest. And the mass of the block, suppose given here 1 kg, and friction coefficient given here 0.5, and the value of G is given here 10 meter per second square. So question is given like, you can write a block of mass 1 kg is in equilibrium with the force F, as shown in diagram. Find the limiting value of force F for equilibrium of the block. Find the limiting value of F for equilibrium of block. For equilibrium of block. Now, we will make FVD of the block. First, see this. This is your block. Whatever the forces acting on the block, first we will see those forces. Before applying F, we will resolve. In this side, F cos 30, upside F sin 30. Apart from that, mg, and third is your normal force. Now here on the block, horizontal force is your NN F cos 30. So there is no horizontal motion. Directly we can say N is equal to your F cos 30. This is your first equation. Now, in the vertical direction, there are two forces, mg and F sin 30. We don't know the value of F. So there are two possibilities. Either the block can go downside. It means if mg is more than F sin 30, or if F sin 30 is more than mg, then it has tendency to go up. So we can have two conditions here. First, if block is moving downside. If block is moving downside means block have tendency to go downside, then friction will act in the upward direction. That friction your F is equal to mu into N. So, for equilibrium, we can write F sin 30 plus F is equal to your mg, and F value we can write here mu into N. So F sin 30 plus F is your mu into N, mu, N is equal to your F cos 30, this is your mg. So F is equal to your mg by sin 30 plus mu cos 30. So this is the, you can say, minimum value of that. Similarly, so this is the case when the block have tendency to moving downward. In the second case, if block has tendency to go up, has tendency to move up. So if the block have tendency to move up because of the F sin 30 is more than the mg, then the friction force will act in the downside. Then if we are making FVD, so one mg is remain there, normal force will be there, but friction will be your downside. Upward your F sin 30, that will remain there, and here F cos 30. Now the equation for vertical direction, F sin 30 must be equal to your small f plus mg, and F is equal to your mu into N. So F sin 30 minus mu, F is your mu into N, this is your mg. F sin 30 minus mu, N is F cos 30 is your mg. So F is equal to here mg by sin 30 minus mu cos 30. So this is the two value of F we are getting. One is your mg by sin 30 plus mu cos 30, and F is equal to your mg by sin 30 minus F mu cos 30 if we are substituting the value of all data. M is given 1, G is your 10, so mg will be your 10 here, by sin 30 1 by 2 minus mu is your 0.5, cos 30 root 3 by 2. It become your root 3 by 4. Now we can say here 40 by 2 minus root 3. Similarly, if we are simplifying this, then we will get a 40 by 2 plus root 3. So finally we can say f must be greater than or equal to 40 by 2 plus root 3, and it must be your less than or equal to your 40 minus 2 root 3. Then the system will be in equilibrium. Then block will be in equilibrium. So this is the one of the example. Okay, now see another example. Let in this example we are having two blocks which are kept on a horizontal surface like this. Let this block having mass 1 kg and this block having let mass 2 kg, and the block which is suspended have mass let 3 kg, and the friction coefficient between the block of mass m2 is your 0.5, and the friction coefficient between the block m1 and the ground is let 0.6. So this is the whole system is given. In the question again we are saying there are 3 blocks: block of mass block m1 mass 1 kg, block mass m2 2 kg, and another block m3 mass 3 kg which is suspended, and the friction coefficient between the block 1 and ground is 0.6, between the block 2 and ground is 0.5, and this is your suspended block. Find the, so now see the what we have to calculate. Find the tension on both the string, friction force between the blocks and ground, friction force between the blocks and ground, as well as acceleration of each block. These are the some point which we have to determine. So first, see here. If we are looking at video of this M1, so what we will find here, normal force here, this here, upper direction, mg or downward direction. So maximum friction between the ground and this block, that I'm just calculating the maximum friction. The maximum friction between the block 1 and ground, that your mu1 into mg. Mu1 your 6.6, mg your 10, so this is your 6 Newton. And when we are looking here maximum friction is here. See here maximum friction, mu2 your 0.5 and normal force is your 20. So this is your 10 Newton. And downward force is here in this block here M3G, and which is 30 Newton. So see, if we are looking whole FVD, suppose this is your at rest, then T1 must be equal to 30 Newton. So maximum friction force is T1, and due to this T1 it has tendency to move on that side. As soon as it has tendency to move here, friction start acting. Maximum friction here 10 and here your 6. The cumulative friction force between 10 and 6 here this will become 16, and T1 here your 30 Newton. It means whole the system will slide. The whole the system will slide. Then we can solve the problem very simple way. If this have acceleration A, this, and this also have acceleration your A, and now since sliding is there, at that time friction between the block and ground is your maximum value. Now we can solve like this. So for 3 kg block, see, for 3 kg block, 30 Newton downward minus T1 is equal to 3A. 30 minus T1 is your 3A. This is your first equation. Now when we are looking for 2 kg block, for 2 kg block, here T1, one another tension T2, here also T2, and it has tendency of motion in that side. So equation here, as T1 act here, so here friction force will act, that your F2, here also friction will act your F1. So T1 minus T2 minus F2, so T1 minus T2 minus F2 is your MA, M is your 2 into A. And now for 1 kg block, 1 kg block, here your T2 and no friction, here friction F1, so T2 minus F1 is equal to MA, M is your 1, this is your A. So this is your first equation, this is your can say second, this is your third equation. Now on adding all equations, if we are adding all equations, to see 30 minus T1 plus T1 minus T2 plus T2, we will get 30 minus F2 minus F1 is equal to 3 plus 2 plus 1, 6A, and this 30 F2 already we have found maximum your minus 10, and F1 your 6, 6A, so A is equal to your 16, 30 minus 16, 14, 14 by 6, this is your 7 by 3 meter per second square. It means all the block have acceleration 7 by 3 meter per second square. Now T2. So T2 will be your F1 plus A. F1 already we have found, that F1 your 6 and A is 7 by 3. 7 by 3. This become your 6 into 3, 18 plus 7, 25 by 3 Newton. And similarly, we can get the value of T1 also. So T1 is equal to your T2 plus F2 plus 2A. And T2 already we have found 25 by 3, and F2 value we have found here 10 plus 2A. A is 7 by 3, so 2A will be 14 by 3. So when we are simplifying here, so 10 into 3, 30, 30 plus 25, 55 plus 14. This is 69 by 3. 69 by 3 means here 23. So 23 Newton. So this is the answer of all part. So tension on both the string In this string tension your T1, that is 23 Newton. In this string tension T2, 25 by 3. Acceleration of each block is your 7 by 3. Friction between the second block and ground is already we have found 10 Newton, and friction between the first block and ground is F1, which is already we have calculated your 6 Newton. This is the one of the example. Now see another diagram. In this diagram, this is your plank of mass capital M. On this plank, a man is standing and he is pulling the string. Now question is that find the maximum force by which a man is pulling the string so that the block remain at rest. So we can write a plank of mass M kept on rough horizontal surface of friction coefficient mu a man is standing on plank. A man is standing on plank and he is pulling a string. He is pulling a string as shown in diagram. Find the maximum force. Maximum force by which he should pull the string. He should pull the string till the system remain in equilibrium. So this is the question here. So what we can do here, just to make FBD. System remain equilibrium means your plank is not moving. So when we are making FBD of the plank, see, this is your plank, mass M, here FBD of plank. So plank is pulled by certain force, that is you can say tension. Another is your weight of the plank. Another your normal by the ground, and another normal by the man and dash. So there is no other horizontal force acting. So because of that tension T, it has tendency to go in the right side direction. So friction. Here friction is that. So that friction F. F maximum is your mu into N. This is the FVD of plank. Now FVD of man. If we are looking the man like this, FBD of man, forces, whatever tension T here, that will go to the here. So one is the tension, another your normal by the plank, and as opposite, and third is the weight mg. No other forces are there. So first, for maximum force, So T must be equal to your T maximum is equal to your F maximum. T maximum is equal to your F maximum. This is the let one equation. Second, C for man. From FVD of man. From FVD of man, we can write T plus N dash is equal to small mg. T plus N dash is your mg. And from FVD of Planck, FVD of Planck, N dash downward, capital Mg downward. So N is equal to your capital Mg plus N dash, third equation. And for vertical, already we have found T maximum is this. Now we can solve from that. So T maximum is equal to F max. F max your mu into N. This N can be written as, see from here, mu, N is your mg plus N dash. Mg plus N dash, and N dash further we can write plus mg minus T. So this T and this T will be same. So see from here, so T you can take common, 1 plus mu is equal to mu m plus m into g. So T is equal to your mu times m plus m g by 1 plus mu. This is the maximum value of force needed till the system will remain in equilibrium. So in this manner we can solve the problem. Now see another example. See another example. In this example we are taking two blocks. One block, let capital M mass and let this value of 2 kg, and on the another block 1 kg of mass. And suppose there is no friction between the lower block and ground, and there is a friction mu is 0.4 between the two blocks. So if we are applying horizontal force F, so what is the maximum value of F so that both the block moves together? So we can write like that. Two blocks of mass 2 kg and 1 kg kept over each other as shown in diagram. As shown in diagram, there is no friction between lower block and ground, and mu is equal to 0.4 between the blocks. Now what we are doing, we are applying a horizontal force on the upper block. Find the maximum horizontal force on upper block till the system remain till both the blocks travel together or move together. This is the main problem point here. Now, if we are looking the individual blocks, see, upper block is this, force is acting on the upper block, and if we are looking the lower block is this. First, as the force start acting on the upper block, so the upper block have tendency to move in the leftward direction. As soon as upper block have tendency to move leftward direction, so friction force on the upper block your rightward. As we know, friction force your action reaction force. If the friction force on the upper block your rightward, then the friction force on the lower block will be leftward. This is the main point here. And since there is no friction between the ground and the lower block, so no friction is there. Now, if these two friction or these two blocks move together, so that friction will be your static friction. And the relative motion will start as soon as the friction force between this your maximum. So static friction maximum is your F static maximum is equal to your mu static into N. If we are making complete FVD here, so normal force exerted by the lower block on the upper block, that your N, weight of this your mg. Normal force here your N, and from here normal your N dash, and weight your mg. Now, Fs maximum, static force maximum is your mu value given 0.4, and this N is your small mg, small m is your 1, g your 10, that is your 4 Newton. 4 Newton is the maximum static friction. So till the static friction is not reaching to the maximum limiting value, both the block will move together. So for this condition, see, we can now check the, we can solve the equation for this equation. See. Now, for upper block, F minus F is equal to your M into A. And for lower block, this is your first equation. For lower block, F is equal to your F, we can say basically maximum. F maximum is your capital M into A. As F maximum is your 4 Newton, so from here 4 is your 2 into A, that gives us A is equal to 2 meter per second square. So if A is equal to 2 meter per second square, it means up to this acceleration both blocks will move together. So now substitute the value of A in the first equation. On substituting, A is equal to 2 meter per second square in equation first. See, F minus F maximum, F minus 4 is your M into A, M is your 1 and A is 2, 1 into 2, the F is equal to your 6 Newton. So maximum value, so answer we can write maximum horizontal force, till horizontal force on, maximum horizontal force on upper block till both the blocks are moving together. Both the blocks are moving together is 6 Newton. This is the answer of this part. Now in the same question, we can slightly change the question here. See that? Now see, small changes I have done in the same problem. In this question, what we are looking here, if the force is acting on the lower block. In the previous question, the force was in the upper block. Now here in the lower block. Same. Find the maximum horizontal force on the lower block till both the blocks travel together. This is the main point here. See, what we can do here, if we are considering both the block, so slipping will start when the upper block will move relative to the lower block. We can write slipping will start when upper block moves relative to lower block. So what I will do, I will make FVD of upper block. So let A is the acceleration of lower block, like this. So this is the lower block, mass capital M, F is the force, let it has acceleration A. Now FBD of upper block with respect to lower block. See, this is your upper block. First, since lower block is moving with acceleration A in the leftward, so first we have to apply a pseudo force on the upper block which is in the rightward direction. Because of that pseudo force, the upper block have tendency to go right side. So immediately the friction force will act in the leftward direction. And as we are increasing the suppose MA force or acceleration of the lower block here increases, friction force also increases. But friction has some limiting value. So that limiting value, up to that limiting value, lower block will remain in contact, or lower block will travel or move together with the upper block. See, for limiting value of acceleration, for limiting condition of togetherness of both the block, togetherness of both the block, F maximum must be equal to mg. F maximum must be equal to m into A. So now when we are looking the F maximum, so as we know here mg downward, here normal force here upward, so F maximum here mu mg, so that gives us A is equal to your mu mg. It means the upper block will remain with the lower block, or both the block will move together till the acceleration of lower block is not mu mg. So when the acceleration of lower block your mu mg, and at that time the friction your maximum, so here friction your maximum, then we can write equation for the lower block. So F minus F maximum is equal to your m into A, and that gives us F is equal to F maximum plus F maximum plus MA. MA is your mu capital mg, and the F maximum value your mu into n. F maximum your mu into n, and mu given your 0.4 and mg your 10, so that your 4 plus mu is your 0.4, capital M is 2, this is your 10, so F is equal to your 0.4, this is your 12 Newton. So here we are getting the answer your 12 Newton. It means both the block will move together when the force on the lower block is 12 Newton. Now see another example. Here a disc is given, and this disc is rotating about the axis passing through the center of mass. Let a small particle of mass m kept at a distance small r, and mu is the friction coefficient between the particle and disk. So find the maximum value of omega till the particle is not sliding with respect to disk. So see the question. A particle is kept on a disk at a distance r from their axis of rotation. If mu is the friction coefficient of disk and particle, find the maximum angular velocity of disk, till the particle is remain at rest with respect to disk. So this is the one problem here. So it means particle is not moving with respect to disk. We have to find maximum value of angular velocity of the disk. So if we are looking first we are making see FVD of particle with respect to disk. Let this is the disk plane. A particle is kept here. At distance r. The first thing, as the disk is rotating, so each and every particle of the disk have an acceleration toward the center. That acceleration is called your centripetal acceleration. So the place where this particle has been kept, that place also have an acceleration toward the center, and that acceleration is given as r omega square. So if we are making FBD of the particle, this particle experience a pseudo force mr omega square in this direction. So, and other forces are here mg and another your normal. So particle have tendency to move in the rightward direction because of this pseudo force. So as soon as it start moving in the rightward direction, immediately a friction will act in this direction, and the particle will remain at rest till that force is not reaching to the maximum value of friction force. So critical condition for particle remain at rest or for maximum value of, for maximum omega, the pseudo force on particle must be equal to F maximum. So we can write here F maximum is equal to your M R omega maximum square, and F maximum is your mu into N M R omega maximum square, and N value equal to your mg. So mu mg is your mr omega maximum square, and this gives us m and m cancel. So omega maximum must be equal to mu g by r. This is the answer of this problem. So this is the one of the another example. In this manner we can solve the problem based on the friction.